respect, when I change x into negative x, it's a reflection with respect to the y-axis. Now, stay with me. Am I changing x? No. So this is the y value, which is the square root of x, or f of x, right? This is the y value. Did I start that? Yeah. So then what am I changing? Right. So I have y, and I'm graphing negative y. What type of reflection is this? Y, negative, exactly. So this is a reflection with respect to the x-axis. Reflect with respect to the x-axis. Here it is. Here's my reflection. So far we covered this. Before we move on to the last two, I would like to create a combo. Here's my combo. Let's say f of x, yes, negative x plus 1 squared minus 4. All transformations have to be presented in the order of operations. You cannot say subtract 4 and then square and then multiply and then shift. No. They have to be in order of operations, as if you're giving me this function and you say plug in 5. What am I going to do first? 5 plus 1. Then I'm going to square. Then I'm going to multiply by negative 1. And then subtract 4. In the same order, the transformations have to be presented. Same order of operations. So first, we have to identify the base function. What is it? It's, right, x squared. Very good. Number 2, in order of operations, which step will you perform next? Very good. What does x plus 1 squared do to x squared? Careful. When we change x into x plus 1, we do this. Which direction? One more time. Where is this 0? At 0. Where is this 0? Not at 1, but at negative 1, right? So this is what again? Horizontal shift of left, because x plus 1 equals 0 means x equals negative 1.
Oh, okay.
How many to the left?
1.
That's it. Number 3. Absolutely. Please. Please. The next step is a transformation on step 2. I'm done with x squared. It's gone. So number 3 is a transformation on number 2. What is it? Negative 1 times x plus 1 squared. Good. What transformation is this? When I multiply, what am I multiplying? Am I multiplying x? Am I multiplying y? I have to decide. Because if I'm multiplying y, is this. If I'm multiplying x, is this. Which one? Exactly. Because from this step till this step, nothing changed in x. So the change is outside. So what does it do? Exactly, because I'm multiplying the y by negative 1. Reflection with respect to the x-axis. Final step, function 4 is on function 3. I have to perform a transformation to get the final function, which is negative x plus 1 squared minus 4. What does this do to this one? Does it change x? Does it change y? What does it do? Exactly. Because still there is no change in x. But this negative 4 pops up. So I'm going this or this. Where? How many? Yes. Yes. Vertical shift of 4 or down 4. 4 down. Now I will have to present all these. Now, forget about graphing it for a second. Can you give me the vertex? Don't say anything for 1 second. So this is my x squared. I'm moving 1. I'm reflecting down 4. Can you give me the vertex without even graphing it?
-1, -4.
That's it. And we haven't even graphed it. But we understood the transformations behind the function and how it was determined. One more time. X squared, left 1, flip, down 4. -1, -4. Very good. So let's do this. And we can do this now with any of those 7 or 8 functions we listed. Just like that. Okay? So here is x squared. Then you told me to shift it 1 left 1. Here it is. So this is x plus 1 squared. Then you told me to reflect it. Okay, here it is. Negative x plus 1 squared. And then you told me shift it down 4. And that's what I'm going to do. 1, 2, 3, 4.
Where did 2x come from? X squared. Sorry.
This one is the base function that we started with.
That equation, I'm still not understanding how you got x squared.
Which I don't know where we are
First
looking. This one?
Yes.
Because I don't see the square root. I don't see 1 over x. I don't see the absolute value. I don't see the cube root.
Okay.
I see something squared. Yes.
Okay.
Yes.
Alright, when we're answering questions such as this, are we going through the steps and adding like all of the lines on the graphs or just the final one?
Oh, I will ask you to graph all of them step by step.
Okay.
Yes. Yes. So you already identified the vertex way before we even graphed it, and you said -1, -4. This will help us tremendously in chapter 3 when we get to graphing your quadratic function.
So I have a question.
Sure.
On the test, you just do like the end function, right? The last one.
You have to decompose it like this. You have to write and tell me what is each, and you have to graph all of them as we graph them now.
Okay, so you want to see all of them.
Absolutely, yes. Yeah. Unless the problem says just graph the last one.
Okay.
Or says find the x-intercepts and the y-intercept and just graph the last one. Very good. Last 2. Let's start with this and then continue with us. Last one. Ready? So now I want f1, which is 2, the absolute value of x. And I want f2, which is 1/2 the absolute value of x. What is the first question? Now you already know what I'm going to ask. Exactly. So what did I use to determine or create f1 and f2? Antoine, is that clear? Okay. So the absolute value of x is the base function. I'm going to graph it on the side. And here it is. Good. Let me illustrate this step by step, so please pay attention for a moment. I hope you agree that when I graph this function, although I didn't show you, but I know it bisects the 2 quadrants. Obviously, this point here must be 1, 1, right? This point here must be, and so on and so forth. This point here must be -1, and so on and so forth. Okay. Now, like before, Chip, are you okay? I have cough drops. Okay. So I'm looking at this and compare it to this, and I have to analyze whether it's a transformation in x, if x changes or y changes. Correct. Because there is no change in x. I'm not adding, subtracting, multiplying x. I'm only multiplying the y value by 2. Okay, so let's come up with a couple of points. When x is 1, how much is f? 1. 2, indeed. When x is 2, how much is this y? And now you tell me on both sides, of course. Sorry, I missed it a little bit. Sorry about that. So you tell me what twice a function will do before you say anything.
Shrink. And stretch.
So this is a vertical stretching of by a factor of 2. By a factor of 2. Vertical stretching by a factor of 2. Now, please give me a couple of points for the other one. Make up 2 points for this one. When x is 1, y is 1/2. When x is 2, y is 1. And I can continue forever on both sides. When x is 1, I have 1/2. When x is 2, I have 1. When x is 4, I have 2. So before you say anything, let me show you what's happening here from this. Or shrinking. So this is a vertical shrinking of the graph by a factor of 1/2.
So when you answer, do you have to put that by the factor of?
No, you don't. I'm happy if you say vertical shrinking. Okay.
The first one was vertical
Stretching by a factor of 2 because you were stretched vertically. And this one is a horizontal shrinking because it was flattened. From here, here.
Horizontal.
Vertical, only vertical.
Okay.
We haven't talked about horizontal yet.
Okay.
I'm sorry.
So if we have a problem, probably will, do we also express this vertical shrinking by a factor?
Vertical shrinking, I'm fine.
Okay.
Yes.
So they're both vertical.
Yes. No.
Just that two.
This is a stretching with when the number in front is greater than 1 is a vertical stretching. When the number in front is less than 1, I have to divide. Here I multiply by 2. Everything multiplied by 2 makes it narrower. Everything divided by 2 makes it flatter.
So we don't have to specify.
No, I'm fine with that. So here's another example. Let's say f of x equals 1/3 the square root of x. How will I graph this? What is the base function? Yes. So let's find some points this time in order to illustrate. So 1, 1, 1, 2, 3, 4, 2. So this is the graph of the square root of x. How will I graph 1/3 the square root of x? What should I do to all y value? Divide them by, that's it. So this divided by 3 is here. This divided by 3 is here. And so on and so forth. This is the graph of 1/3 the square root of x. Last one. At least initially, you may not like this one. So we're done with everything except the one that I said. So this is done. Vertical stretching and shrinking. The factor has to be in front greater than 1 or less than 1. So horizontal. Ready? I want to look at the function f of x, which is x cubed. And using this function, I would like to create the function f1 twice x and function f2 1/2 x. Okay, so allow me to illustrate. I know I look funny, but maybe that will trigger your memory. Okay, ready? This is x cubed, right? Did I list it? Oh, I forgot. I need x cubed. Oh no. I have the cube root, but I forgot to list x cubed. I'm sorry. I need it. So allow me to add it in. We used it when we looked at the odd function and we illustrated with it, but I forgot to list it. Sorry, this is the last one. For now. So here's x cubed. So can anyone give us, I did a cube root, but I forgot to use it. Okay. Can anyone give us the simplest possible cubic function? I thought I could trick you. Okay, so here it is. This is the graph. We used it before, but I forgot to list it. Is this odd, even, or none of the above? Of course, it's an odd function. Okay, so now I can look silly then. So here is x cubed. Agreed? Good. Bless you. So I would like you to tell me, how do I get this? Not the graph. Just give me the expression. What should I write? Very good. Do you all agree with this? For now, don't do anything to it. I need to explain. Do you all agree with this? And how will the second one look like? 1/2 x raised to the? Good. Awesome. So now please simplify the first one. When I raise a product to a power, I raise each and every factor to that power. So please simplify 2x to the third for me. Very good. So now, for a moment, bear with me. Forget where this came from. Forget it. Okay? So I would like to graph 8x cubed. So this is my x cubed. And the number in front is greater than 1. So what would the graph do? This or this? This one, right? So pay attention to what I'm doing. So this is x cubed. And now I want to graph 8x cubed. It's a vertical stretching. But horizontally, what happens? Let's look again. Yes. Well, what did I do to x? I multiplied it by 8. You would have expected this to happen, right?
No. This is the x by x.
Or you're multiplying x by 8.
Horizontal moves opposite of the way you would think it.
That's true. Okay, wonderful. Perfect. So this is x cubed. This will be 8x cubed, but horizontally it's a horizontal shrinking of the graph. One more time. This is x cubed. 8x cubed does this, but at the same time shrinks the graph horizontally. Awesome. So when we change x into twice x, it's not this, but horizontal shrinking by a factor of 1. So twice x will be this graph. So then this, when I change x changed into twice x, it's a horizontal shrinking by a factor, not of 2,
8.
of 1/2. Well, in this case, you're right, it's 1/8. But when I change x into twice x, it's a horizontal shrinking by a factor of 1/2.
How do you get 1?
Okay?
Or we divide
Exactly.
8.
So which one did you graph in green?
I'm sorry? The green graph is f of twice x. Now let's see what happens with this last one here. 1/2 cubed is 1/8 times x cubed. Let's go back. Here's my x cubed. 1/8 x cubed. Will it do this or this? Yes. What does this mean horizontally?
Stretch.
Yes. Exactly, by a factor of 2. So the new graph will be this. And this will be f of 1/2 x, which is a horizontal stretching by a factor of 2. This is the end, so then we can play with it. Okay. I want to show an example of how, for people who will end up maybe using modeling. For example, let's say because I'm sure you're wondering, okay, yeah, you can picture a graph in your head, so what? Here's an application in a real life situation. Here it is. Let's say we measure, this is an example in your book. It's a very nice example. On page 296. They measured heights of babies from the moment they were born till several years later, several months later, maybe 60 months or more. And this is what they came up with. So they investigated, they measured, I don't know, 2,000, 10,000 babies from the moment they were born till 60 months old, and they measured them, their height, okay? And they came up with this. They graphed each and every point. Let's say, I'm coming back in a second, bless you. Let's say in another study, whatever they were studying, they came up with these points. What would you suggest to these researchers? What function would you suggest for the heights of babies? A square root, possibly stretched, I don't know, but also shifted up, blah, blah, blah. What would you suggest to this researcher? Right, shifted to the, so you can come up with your own function. Okay, so let's look at a problem in the book. You want to work on this problem that I just mentioned, or another problem? Is that okay?
Yeah.
Okay, so this is problem 128 on page 296. Because it's nice to illustrate in real life when we apply this on that, because I know this is always on Tim's mind. So I have to answer before he asks, because otherwise he comes up with ideas, and I don't want him to have ideas. Just kidding, Tim. Yes. Okay, so now I'm hoping you're fine and happy. Okay, The function f of x equals 3.1, the square root of x plus 19, models the median height f of x in inches. So this is, I'm taking notes as I read. Median height in inches of girls who are X month of age. X months. Perfect. The graph of f is shown. They show the graph. Describe how the graph can be obtained using transformations on the square root function. Please explain. First transformation is?
Basic function square root of x.
Yes, that's the base function. The first transformation on the base function is? By stretching it by a factor of? Yes, because I have to present everything in descending order, in the order of operations. And then after I stretch it by a factor of 3.1, how much? 19. Part B. According to the model, what is the median height of girls who are 48 months or 4 years old? How do I determine? According to the model, what is the median height of girls who are 48 months old? That's it. So in part A, I'm going to say 3.1 vertical stretch, because I want to write something for you. 19 up 19 plus 19 up 19 units. So B, f of 48. I recommend this. Going to the graphing calculator in y equals, clear if you have something, put 3.1 times the square root. Where is the square root here? Square root of x. And outside plus 19. After you plug in the function, go to second and table. And what do I'm sorry, this is going back always to default. Make sure that your independent variable is in the ask mode. Independent variable in the ask mode. And then second and table, what do I want to plug in? Okay, let's read 48. So 40.477 inches. 477 inches. According to the model, a girl who is 48 months old should have a height of 40.477 inches. It says round to the nearest tenth of an inch. The actual median height for girls at 48 months is 40.2. So that's the actual. They want us to round to the nearest tenth of an inch. So what will you say? So you will say 40.5. And here's the question. The actual is this. The model gives us this. I'm sorry. Okay, F48. We had 40.477 inches. Forgive me for that. And this is 40.5. But they are telling us that the actual was this. The model cannot be perfect. But now the question. How well does the model describe the actual height? Very well, right? 40.5 versus 40.2 is very good. Very good approximation. The model at 48, I don't know at other heights, I have no idea. But at 48, it appears that the model is a good representation of the median heights. Good, very good. At 48 months, I have no idea. I can't conclude. I haven't looked at other. Part C, use the model to find the average rate of change in inches per month between birth and 10 months. Average rate between birth and 10 months. What do I have to write? f of,
x1
yes, x2 minus f of x1. That's the formula over x2 minus x1. Perfect. So now we'll write f of 10 minus f of 0 over. Very good. So let's plug them in. I go back to my calculator. I plug in 0 and I plug in 10. So I have the values. Can anyone dictate what I should write? What is f of 10? 28.8 minus f of 0, 19 over 10 minus 0. Is this clear? I determined with the graphing calculator this, and I determined this and this. So 28 minus 19 is 9.8 divided by 10. So 0.98. Remember what I said about the measurement unit? It's a ratio, the top measurement unit over the bottom measurement unit. What is it? What is the measurement unit for the top? Per? That's it. So what does this mean? It appears that according to the model, the girls grow on average almost an inch per month. Good. Last question here. Use the model to find the average rate of change in inches per month between 50 and 60. Final question. Average rate between 50 and 60. So I have to find f of 60 minus f of 50 over 60 minus 50. Question. Which of these two rates before we determine the second one should be faster, should be larger? Right. Between 50 and 60, the growth slows down. This is what we expect. Let's see if that happens. I go back to my calculator. I plug in 50. I plug in 60. And I get 40.92 minus 43. Yeah, I replaced. Okay, I'm going to have to write it again. So it's 43.012 minus 40.92, of course, 60 minus 50. Sorry about that. I copied the first one. So it's 43.012 minus 40.92 over 10. So what do we get at the top? So 43.012. How much? 2.09. Very good. So very good. So this is 0.21 approximately. Without the measurement unit, this means nothing. What is the measurement unit? So between 50 and 60 months old, the girls appear to increase their height by 0.21 of an inch as we expected. How does this compare with your answer in part C? Much slower. How is this difference shown by the graph? So we see it here. The graph is this. Of course, right here, the increase is much steeper, and here it levels off as expected. So that's a typical application of the average rate of change, transformations, typical real-life situation. Any